So the reason we were practicing factoring on Friday was ultimately to be able to get to a situation where we could solve a quadratic using factoring. We've solved quadratics now using graphing. Today we're going to use factoring to help us do that. And in order to understand why factoring works and how it works and where the solutions come from, I want to go back to looking at a graph first. Okay? So here's a picture. You can find this on page 570 in your book. If you'd rather take a screenshot from the book, you're welcome to take a picture of the screen, but go ahead and do that and get it situated in your notes, and then I'm going to talk through all this so you've got an idea about where it all comes from. So I want to connect our graph to our factors, to our solutions and roots and zeros, and look at all of those things together and see how it's all connected. So here's what's happening. All right, if I go to the graph, all right, what are the solutions based on the graph? 2 and 6. Okay, the x-intercepts are the solutions, 2 and 6. Okay, and we can pull that right off the graph. We did that in 4.2. Right, here's the equation in standard form. So if you were to have plugged this in your calculator, y equals, this is the graph that you would get. Okay, this is factorable. Factors of 12 that add up to -8 are -6 and 2. So I can factor this out. Now notice here, my solutions are 2 and 6, and inside here I have -6 and -2. That's not a coincidence. The solutions can come from the factored form. So the actual solutions are opposite from the signs. So the factors, the solutions are 6, +6, and +2. And we already verified that from the graph. So when you have it in factored form, you just can pull off the solutions knowing that the sign is going to be opposite of sort of what it looks like. And in a few slides, you're going to see why that is and why that works out like that. That the signs are always opposite that way. Okay. On the next thing that I'm going to add to this is going to be a bunch of arrows that are color-coded. So you can kind of see where this -6 and 6 connect, the -2 and 2 connect. Okay. So the green arrows to the -2, and then the 2 to the 2 as the solution, the red arrow to the -6, and to the 6 as the solution. Now the reason why this is important and showing you this first is because one of the things that you're going to have to do is you're going to have to write an equation given the solutions. So one of the things you're going to have to do is they're going to say, here are 2 solutions for a quadratic, write an equation that would go with that. And so in this case, if I would have told you 2 solutions to a quadratic are 2 and 6, write an equation for it, you would have gone to this. Okay? And again, these signs being opposite. So let's look at an example. This is something you're going to do in your homework site. Write a quadratic equation in standard form with 3/4 and -5 as its root. So go ahead and write that down, and then we'll kind of work through it together. So here's what we're going to do. Since there's 2 solutions, we're going to have 2 binomials. Okay? And they're either going to be x minus or x plus. And with our numbers, those will determine whether it's minus or plus. So think back to the previous screen and how the factors, signs, were opposite from the solutions. So what's that factor going to be for 3/4? X minus 3/4 or x plus 3/4? Minus. Since it's positive, it goes in as minus. And in this one, since it's already negative, it's going to go in as a plus. Okay. So this is where I start. Okay. I take my root, put it in with the opposite sign, and I have 2 binomials. Right. Now what I want you to do, and it always equals 0. Okay. Set it equal to 0. What I want you to do now is we have to put it in standard form. Remember, standard form is ax squared plus bx plus c. What else is true about standard form? What do the coefficients all have to be? A has to be positive, they have to be integers, okay? So what I want you to do is multiply this out. I want you to try to simplify it as far as you can and get it into standard form. Okay, so we're going to FOIL this out. When we do that, we get this. Now I simplified already the middle terms. If you still had 5x and minus 3/4x, that's fine. Okay? There's no reason to change these to mixed numbers. Do not do that. Because eventually, to get it in the standard form, we have to get rid of all what? What can't we have? Yeah. Yeah, you can't have fractions and it be in standard form. So I have to remember that there are no fractions or decimals in standard form. So I've got this problem with a bunch of fractions in it. How do I get rid of the fractions? We talked about this earlier in the year. Multiply by 4. Be just in general. For 4 for this one, but what are we, in general, what are we doing? By the common denominator. Common denominator. In this case, since the common denominator is the same, I'm just going to multiply everything by 4. Both sides. Okay, so notice here, I did it there and there. You got to multiply everything by 4. So that means I'm distributing. Obviously, the right-hand side is still 0. 4 times 0 is 0. So, what I should get, 4x squared plus 17x minus 15 equals 0. That is a quadratic equation in standard form that has roots 3/4 and negative 5. Now, I will tell you that is one possible answer. There are many other equations that you could have with those same solutions. However, they will all end up being multiples of this. Okay? So if for some reason you thought that the common denominator was 8 instead of 4 and you multiplied everything through, you would still get an equation in standard form that had those roots of 3/4 and negative 5.
So there are multiple answers.
Possibly. So long as you multiply through by the lowest common denominator, you'll get the same equation as everybody else. Okay? So this is part of your homework. They're going to give you a couple roots. You're going to plug it in the correct way, multiply it out, and simplify. Okay? And that's where that's going to come from. Now, more often what you're going to do for tonight's homework is you're going to actually solve the quadratic equation by factoring. So we're going to have the equation to start with, we're going to factor it out, and then we're going to find the roots. Okay, and here's how we're going to do that. Solving by factoring requires us to do several steps. So here are the steps we're going to follow to solve a quadratic by factoring. First of all, like we did when we were solving by graphing, we need to make sure that one side of the equation equals 0. A lot of the times it's going to be set up for us in that way, but don't try to start factoring anything or trying to solve anything unless you have that one side equal to 0. There are other methods that we're going to look at later on in chapter 4 where that doesn't have to happen, but to solve by factoring, it has to happen that way. Okay? Once you get that done, you're going to factor the equation. So that worksheet that you did Friday or over the weekend, now you're going to apply all those different factoring strategies to the equation. Okay? Because really factoring by itself is just a tool to get us to be able to solve quadratics. And each set of parentheses that you have left over after you factor, those are factors of the equation. Okay? And so you're going to set each of those factors equal to 0, and you're going to solve. Let me explain why this works. Okay. And I want to use the first example that we had. We had x minus 6 times x minus 2 equals 0. So I have one thing times another thing, and they equal 0. So in order to multiply two things together to equal 0, at least one of them has to equal 0. So either this equals 0, this whole thing equals 0, because 0 times anything is 0. This whole thing can equal 0, because anything times 0 equals 0, or they both can equal 0. So this is why the idea of setting each factor to 0 and solving is important. Because in order to have a multiplication problem that results in 0, one or both of them have to be 0. Okay? So let's do some examples. Here are two examples that we're going to work through. Okay? I've set them up for you so that one side is already 0. I've done step 1 for you. What I want you to do is steps 2 and 3. So factor each equation and then set each factor equal to 0 and solve. So see if you can come up with your solutions. My guess is you've done this before too. Let's look at the first one. Okay. Is there a greatest common factor?
Yes.
What is it?
9x.
9x. Okay, so I need to put a 9x out in front and then divide everything by 9x. One of the things we talked about on Friday, if you start off with two terms, inside the parentheses you should still have two terms when you take a greatest common factor out. So 81x squared divided by 9x is 9x. 9x divided by 9x is 1. Now, I have two factors, even though only one of them is in parentheses. 9x is one of my factors. 9x minus 1 is the other. So I have to set both of them equal to 0 and solve that. Now, over here, I'm dividing by 9. What is x going to equal? 0. What about here? What do I have to do? In order to get x by itself, I have to add 1 and then divide by 9. So what's my solution going to be over here? 1/9. Okay, those are my two solutions. So we're using factoring as a tool to get to the solution, to the root, to the 0. Okay? Any questions about that? Is there a greatest common factor over here?
No.
Nope. It's in descending order, x squared, x constant. Factors of negative 21 that add up to negative 4. Negative 7, positive 3. Okay? Now, I've got two factors again. Okay, this is a lot like the first example I showed you. What's the solution going to be out of this? 7. It's just the opposite. Out of this one? Negative 3. Now, I can set them equal. X minus 7 equals 0. X plus 3 equals 0. Okay? Or I can jump right to the solution when you know what it is. Okay? If you wanted to solve the equation x minus 7 equals 0 and fill that in the middle here, you are more than welcome to do that. I'm also giving you the permission to jump right from here to here.
So both at one time.
Correct. If you want to write it and put them both equal to 0 and solve it that way, you're welcome to. But if you recognize that it's just opposite signs, when it's x, see, it doesn't work like that over here, right? It wasn't positive 1 wasn't my answer because there was a 9 in front of the x. Over here, there's nothing in front of the x other than a 1, so you can jump to the answer. Okay. That's what you're doing today. Okay, you're going to be writing quadratics from roots, and you're going to be solving quadratics by factoring. Okay. Remember, when you solve by factoring, you are determining what x equals. Okay. Any questions?